go over this quiz. Hooray. So today we looked at protocols. What is a good definition for a protocol? Anyone ever heard of a protocol before?
Yes.
How would you describe a protocol? A list of prerequisites to inherit a title. Okay. What do you think that means? Okay. Anyone else? Phoenix?
A list of things, whatever you're like, a list of things you have to include if you want to conform to it.
A list of things you have to include in order to conform to something. Cool. I like that. So, how would you describe this word prerequisites?
Things that are required if you want to inherit from it.
Yep. So things that must be included in order for you to inherit from a title. Interesting. Yes?
So would that be similar to C, but just including a struct as well, where I guess would be like the number of functions your class or struct need to implement?
I would think of this a little differently because the third one is a set of functions. It could be properties as well. It doesn't necessarily need to implement, but instead it's like choosing to inherit. Like your code can work without using any protocols, but you use protocols for a specific reason. Let's look at some protocol code. Ian, can you walk me through this example?
Sure. What will the below print?
That's wrong because it's a compile time error.
I also think there's going to be a compile time error.
So we have a protocol, we're defining a person that has a name, which is a string, and a function which takes nothing in and returns a string.
And we've got a fellow that conforms to that protocol, right?
Yes.
Does it conform correctly, I guess is my question here.
Because your function doesn't have void.
Yep, so it returns void. Print is a void function. And so it's not conforming to the blueprint that the protocol actually drew out for that eat function.
So that was just returning string.
That's correct. So if it was returning nom, it would fit this return type. But it does not. I want to thank Angela for being the star of our quiz today. Thank you, Angela. Well, later on. So we get a compile time error because this struct attempting to implement and conform to this protocol person does not conform in the correct way. Cool. Let's keep looking around. Angela, tell me about this question. So it's going to print nom. Okay. So is there anything wrong with this? Mm-hmm. Cool. So would you say it conforms to this protocol properly? Cool. Thank you. So this will just print nom. Amazing. Here's a question. Michelle, can I ask you to help me out with this question?
The compile time error because the struct would have a let.
Tell me more.
Struct has a let.
So why is that let not conforming to the protocol?
Because the protocol is var.
So it's always going to be a var in the protocol, but what specifically about that name property? Yep. So if this let can't be changed, that means that it can't be get set. So the protocol says we should be able to both receive the value for this property name, but also change it. And the struct fellow that's attempting to conform to it doesn't let you change the property name, so it's not conforming correctly. The definition of a fellow does not use name in the way that the protocol person said to use it. How do we feel about that? Cool. So we end up with a compile time error. Swift recognizes that you can't do that. It's not conforming the correct way. All right. Now we really go under the hood with what a person is. Eric W., can I ask you to walk us through this question? Question number 5.
This one wrong though. I just the name would answer.
This one?
Yeah.
Okay. So if it wasn't the first one, what might have happened? Should we throw it into a playground and see what it says is wrong? Let's take a look. So I'm going to try to run this, but I'm going to get some errors. Apparently my struct doesn't conform to organism, which is interesting, because I'm trying to conform to a person. But protocols can actually themselves inherit from other protocols. And so if someone conforms to person, they must also conform to organism. And so fellow doesn't implement that organism protocol because, there is no genus in this struct being implemented. So it's not like inheritance for classes where I would get that property to use. I wouldn't have super.genus, but instead, when you inherit with a protocol, you have to explicitly implement both the protocol you're inheriting from and any of the protocols that that protocol might have inherited from. So one of the really super important things about protocol inheritance is that you still have to be explicit about all the properties and the methods being implemented. It's not like subclassing and superclassing where your subclass and your superclass could contain the properties or the functions of what you've inherited from. And so right now, even though fellow implements person or what's defined in person correctly, it still also needs to implement what's in organism, which is that genus property, and therefore we have a compile time error. With some questions about protocol inheritance. All right. What will this print? So given what we just said about protocol inheritance, will this work? I also think it'll work because we implemented all the properties both of the protocol we are implementing, person, and the protocol that it inherits from, organism. So we've got a name in our struct, we've got a genus in our struct, and we've got this eat function in our struct. So it'll do what that eat function says to do. This last line, we're going to be a little controversial about it. I'm going to say that this line itself prints out void. So this print statement is going to print void. Calling eat is also going to actually print out print nom nom nom. I, Angela, am a awesomeness. Yeah. But this print statement itself is going to print void. So a byproduct of evaluating this Angela.eat is that we get printed out a certain statement, but printing out the last line here gets us void. So you're going to see two print statements, but my controversial take is that printing this, so this line where we print prints void. Amazing. All right. What will this print? Yeah, it's the same thing as before. It just didn't print out a void function. So
Because
it,
we don't have the print statement in front.
because this function itself prints. Cool. Void. Awesome. Liana, can you walk us through number 8? Okay. What is different than the previous question? It's one word. Say it louder. Yep, this optional. So we've seen in the past that something like a UI table view delegate, which is a protocol, has optional methods. Let's see if we can do that with this organism. We're going to see a compile time error. So it can only be applied actually to members of an Objective-C protocol. So it should apply to classes because, spoiler alert, there aren't structs in Objective-C, and there aren't enums in Objective-C. And so whenever in our code in a UIKit function we've used an optional protocol, it's needed to run on the Objective-C runtime for probably a UIKit thing, right? And what this means is that any protocol that implements an optional property or an optional function can only be used on a class. So to step back, a protocol that's gonna have optional properties or optional functions needs to be implemented as an Objective-C protocol with Objective-C properties and functions. And that means, because Objective-C doesn't have structs and enums, we can only implement those protocols on classes. Amazing. And so, in the example we have right here, this protocol just isn't declared properly. We can't just put the word optional in front of a variable to make something work. So there's going to be a compile time error because that's not the proper syntax for an optional protocol. Given what we just said, though, here is a protocol that I've implemented properly. This organism has that Objective-C flag, and it has an optional property called genus. But is this going to work?
No.
I agree. Sam, why isn't this going to work?
Which question is this?
Number 9. Okay. Alex, can I pass to you? Okay. Let's look back at this definition we just created. Here's that protocol. Let's look at our error. Alex, can you read this error set?
Non-class set fellow
Mm-hmm. Yep. So fellow is not a class. It can't conform to an Objective-C protocol. Only classes are going to conform to an Objective-C protocol. So this one will get us a compile time error. Drat. Let's keep going. Knowing what we know, Jack, can I ask your assistance? I want my Objective-C protocol to work. Will it work here?
It will work if you have an initializer, but
Damn, I forgot that about classes. We need an init function if there aren't default values. So this still doesn't work. Well, let's keep going. Eventually my code will work. Nima. So for question 11 here, I've got this protocol that runs as an Objective-C protocol. It's got this optional property. Oh, it's going to be really tough. But Objective-C protocols, they only... I just remember someone told me something about when Objective-C protocols work. Will they work on this fellow protocol? Damn it. Okay. So we're going to get a compile time error? Thank you very much. All right. How about now? Levi, on question 12, I've got this Objective-C protocol organism that has this optional genus, and then a person protocol actually inherits from that organism, and then I have a class fellow with an initializer for a name, but it doesn't have a genus. Is this going to work anyway?
Your number 12 is bad line number 12.
That's okay.
No, that's not gonna work.
Let's see. So I've got a class, implements person, person implements organism. Actually, person inherits from organism, but I don't have to implement any of the stuff from organism because I've got this optional keyword. And so a fellow can conform to person and actually conform to that organism protocol without implementing any of that stuff. Just like you can conform to a UI table view delegate without implementing any of its methods, you do conform, just they're all optional. So you might have let p equal UI table view delegate, and it just looks like that. Hold on. Let's redefine this, sorry. Fellow, we could extend to conform to UI table view delegate. All of UI table view delegates, well, it's not going to work there, don't worry about it. Okay, all of these are optional in this protocol. So whenever we conform, we tend to have something like this. Let's look at why it doesn't work right now, though. Ah, amazing. Fellow doesn't conform to, let's look at that error again. Ready? Go. Fellow doesn't conform to NS object protocol. Has anyone ever seen that in their code before? All the time. Interesting. You might have seen a solution to it very often as well. So, UI table view delegate is a protocol inheriting from UI scroll view delegate, which is a protocol inheriting from NS object protocol. That's some kind of Objective-C thing, right? Generally, that's why the given protocol, you'll tend to see what we call class-only protocols. So to get a protocol that'll work for any class, but only a class, so something like this, you tend to see that protocol inherit from this other protocol called any object. Implementing it right now, not worth our time. But when you see a protocol inheriting from any object, the developer is telling you specifically, even if you don't see stuff like this, even if it just looks like a normal protocol to you, if your protocol inherits from any object, it's meant to be a protocol that only applies to classes. We call that a class-only protocol. Should we say that again? If a protocol is meant to only apply to classes, we have it inherit from any object to make sure it inherits all the classy stuff that is used in both Swift and Objective-C. So in order to properly bridge from Swift to Objective-C, we need some certain things built into here. If we look at any object, oh, it's a type alias. I hope we learn about that. I don't know. It's a protocol to which all class types implicitly conform. You can use it as the concrete type for an instance of any class. All known Objective-C class methods and properties are available as implicitly unwrapped optional methods and properties. So there are certain things that we're used to seeing in classes. Those are all implemented from this any object protocol. A struct is just a struct. If it doesn't inherit, then it doesn't have anything. But a class, by default, needs to have an initializer. Needs to have something called this get default value. There are a whole bunch of things under the hood that must be available to a class. And those are gotten from this protocol, any object. Amazing, right? I know, it's incredibly confusing. That's what makes it amazing. So let's go back in time a little bit. My struct can't do this, my class can. So my class here can have an optional genus and still work without actually implementing it. Therefore, Angela can eat.
What number is that? Is that 12?
12.
Did you later change it to a class?
Yeah, like a minute after the quiz started. Yeah. Okay. It should have regraded to say it was correct. All right, we've got some more code. I've got this Objective-C protocol here with an optional property. Person is a protocol inheriting from it. Pets implement organism. Fellows implement person, which implement organism. But, Anthony, I have a question for you. Will this code work? Number 13. Okay. Let's pass it to Kimball. Why won't it work? And so what won't that work with? What has to be a class? I'm sorry. So what's not a class? What is that not compatible with? Okay. Hildy? Yep. So where can't we use that? Which struct here? You pointed and winked at it, but what's it called? Yes. Okay. So fellow that implements person, which inherits from organism, can't implement an Objective-C protocol. So we're going to get a compile time error saying this struct can't do that. Go away. No more forever. This code doesn't work. What about this code? I got rid of that Objective-C stuff. Is it going to work now? Eric, you've got this look of like, I really want to tell you. It will work? Can you walk me through what's going on down here? Let's put it in a playground. So I've got protocol. Pet implements one of those protocols. Fellow implements both of those protocols. Protocols, there we go, that's the word. And then down here, can you walk me through lines 29 through 34? What kind of closure is that? It's not quite a map. For each is different from a map. How so? Yeah, it's a pretty good way to put it. Doesn't change. Looking for a different answer though. A map is going to try to return you something for each element. For each is just going to look at each element and do something. So if we mapped this, it would return an array of void because print is an array is a void function. For each just goes ahead and does that. So here's the $12 million question. Why do lines 32 and 33 work? Say that again? So they don't inherit, because protocols don't have inheritance into explicit types like these. So they're not children. It's a different kind of relationship. They're not subclasses, because structs don't subclass. What do we say about something when it implements a protocol? Let's throw it to Aram. Yeah, what do we say about that something? Yes. So fellow and pet both conform to the organism protocol. They don't inherit, because inheriting means that you would receive actual properties and functions. Instead, they just get a blueprint for what they should be making. So there's no implementation in a protocol, which means that you don't inherit behavior or properties. All that said, why do lines 32 and 33 work? So they conform, but this is an array of organisms, not of fellows or pets. Why does that work? How does this work even though this array is an array of organisms and not fellows or pets? They conform to organism, and we can use protocols as a type. So we can explicitly say, we should have an array of organisms here regardless of how organism is implemented or what types it's implemented into. So I could have fellows, I could have pets, I could have bugs, I could have, I don't know, plants. Not feeling too creative. And what that means is that whenever we look at organisms, if we look at organisms.first, it's only going to give us the behavior of an organism. So even though I've appended Angela first, I can't go ahead and get Angela's name because it's not a property of an organism. So if I go and look at the first element here, it only knows that it's an organism. I could downcast it to maybe be a fellow. And then I could maybe use the name property. But in this array of organisms, it only knows that it has organisms. You can't use those as any other type without some downcasting or some typecasting or anything like that. Protocols rock. So it worked, Eric. We did it. Amazing.
We call it downcast because it only goes down via the chain, you can't upcast.
What would upcast mean? Okay. Don't know why we call it downcast, but it seems to make sense when we say it. All right, Phoenix. Is this code going to work? Number 15. Cool. What changed between this and the previous question? So this guy's always been a class.
No. You took out the objective function, so it's the protocol conforms to, the structure conforms to the protocol now.
I took that out a little while ago, actually. I changed something about one of the definitions.
Wait, are we on 15 or 16?
15. Here, let's go back to 14. You don't have to do this blind. So, here's the stuff in 14. This all worked. I had a protocol, another protocol inheriting from that protocol, a pet implementing organism, a fellow implementing person. Even though these are classes and structs mixed up, they still worked in this array because they're both organisms. And then if I go and I look at the next one, number 15, something changed about my pet.
Oh, you just added a new variable owner.
Mm-hmm.
And yeah, then you initialize
Cool. So will this work? All right. So just added a new property to a pet called the owner. And yeah, I just added an owner to my pet when I initialized it. Great. Last question. Here's something very fun, so fun, about our protocols. What changed here? Hey, Albert. Kimball.
You add type alias caretaker.
Yeah. What does that mean? What is a type alias? When have we seen a type alias before? I'm sorry? Say again? Protocols can be rewritten as type aliases. We've seen one. Yeah, we've seen this guy a lot, right? Codable is a type alias for two different protocols. Codable itself doesn't even implement anything. Codable, the line that defines Codable, is just one line. It's just saying, hey, if you want to use these 7 characters together, that means that you have both the protocol codable and encodable. So it can be reassigning behavior, it can be combining behavior, or in the example we have, it can just be giving a better name to a certain type in the context that we're using it. So a type alias is literally that. It is providing a different name for a type. It's not renaming a variable. It's just saying, hey, in the context of a pet, when we talk about person, it might make more sense in this context to call it a caretaker. And how that works out for us is if a pet has an owner, which is a person, and then I go ahead and say owner, person, self.owner is equal to owner. That's nice. If I set up my type alias, caretaker is going to be person, then just like we saw with codable, where the type wasn't codable when this popped up, but instead it was what we actually aliased from, the type for a caretaker is not caretaker. We haven't changed any definition. We've just said you should call this that thing. So caretaker, in this context, anything of the type caretaker is actually just of the type person. So I can use anything that I want to call a caretaker in this context as the actual person type. Phoenix. Kind of like type annotated.
Like if I had a variable caretaker and then I just type annotate as a person, I could do the same thing here.
You could, but a good example of this might be if a pet had a feeder that was the person feeding it and a feeder that was the object that provides their food, like a bird feeder. You could use type aliases to say like human feeder should be this property in this context. Like it lets you be more explicit about the types that you're using in that context. So, like with Codable, we can type alias to combine behavior, or we can literally just make things more readable using type aliases. Hmm? Sure. All right. Wonderful. Thank you, everyone. This afternoon, you have pro skills, I guess. I think Estishna will be in for a short announcement about that at some point. We'll check in. But otherwise, you're